Hello everyone, welcome to my YouTube channel. So in this video I am going to solve question number 6 and 7 from exercise 9.1. So in question number 6 it is given that a 1.5 meter tall boy is standing at some distance from a 30 meter tall building. The angle of elevation from his eyes to the top of building increases from 30 degree to 60 degree as he walks towards the building. Find the distance he walked towards the building. So first what we will do, we will draw the figure by reading these questions line by line. So first it says that a 1.5 meter tall boy. So let's draw, this is a boy, 1.5 meter tall boy. Now the boy is standing at some distance from a 30 meter tall building. So this boy is standing from some distance from 30 meter tall building. So let's assume that this is a building which is 30 meter long. So this is the building, the length of this, height of this building is 30 meter. So this is 30 meter. Now this boy is standing some distance away from this building. Now it says that the angle of elevation from his eyes. So let's assume that this is his eyes. Now the angle of elevation from his eyes to the top of building increases from 30 degree to 60 degree as he walks towards the building. So it says that, so at this point if he watch the top of the building, then angle of elevation is 30 degree. First the angle of elevation was 30 degree. Now it says that as he walks towards the building, then the angle increases from 30 degree to 60 degree. Suppose he reach here, so at this point the angle of elevation is 60 degree. Now we need to find the distance of this, how much distance he walks towards the building. So we need to find the distance of this one. So this is our figure. So let's draw this figure. So first the angle of elevation was 30 degree. So this is 30 degree. Now it says that as he walks towards the building, the angle increases from 30 degree to 60 degree. So as he walks towards the building, so suppose he reach here, the boy reach here. So now the angle of elevation is 60 degree. So this is the angle of elevation, 60 degree. So we need to find the distance he walked towards the building. So we need to find the distance of this one, of this distance, how much distance he walked towards the building. So this is our figure. So how we will find this distance? See, if you see clearly here, we can see that there is a two right angle triangle is there. So see, one is there, this is one right angle triangle, and another is, see, this one is also a right angle triangle. So from these two right angle triangle, first we will find, we know the value distance of this, we know this distance and also this distance 1.5. So this is the height of boy, this is 1.5, and this is the height of building, which is 30 meter. Now from this triangle, see, there is a one triangle, this is one triangle. So from this triangle we can calculate the value of this side, since the total is 30 meter. Now if we minus this one is, we know 1.5, since this and this is same. So this one is 1.5. So from total 30 minus of 1.5, we will get this side. So we have one side of a right angle triangle, then we can calculate this side, since we know the angle of this is 60 degree. Now if this is the angle, this is B and this is P, perpendicular. So we know the relation between P and B. So from that relation we can find this value. Now from the next triangle, see, this is another triangle. From this triangle we know this value, we will calculate this base. Again from P and B we can find this total length. Now we know both this total length and this length. So from this total length, if we minus this length, then we will easily get this length. So first let assume that this is A, this is B, and this is C, and this is D. So we need to find the distance of this AD, length of this AD. We need to find this one. So how we will find this one? So first we will calculate total this AB. Total AB, we will calculate AD will be AB if we minus AB minus of this BD. From AB if we minus, see, from this total length AB, if we minus this length BD, then this AD will be left. So AD will be calculated AB minus of this BD. So we need to first calculate AB and this BD. So how we can calculate this BD? This BD we can calculate from this triangle BCD, from the triangle CBD. So you write here solution from the triangle this CBD or DBC from the triangle here DBC, theta is equals to how much? 60 degree. See here, from this triangle theta is 60 degree, and we will find this length BC. BC will be equals to, so let's see, this is X, this is Y. So total CY and this AX, length of AX will be equals to BY. Since this line and this line are parallel, so this BY and AX will be same. So you write here height of boy AX equals to this BY, which is equals to 1.5 meter. This is given, and also we will calculate this BC. Now total this CY is 30 meter. Total CY equals to 30 meter. This is given. Therefore BC will be equals to how much? BC will be equals to total CY from this total length CY minus of BY. So if you subtract BY from CY, then we can get the B length of BC. CY is 30 and BY is 1.5. So BC, length of BC is 28.5 meter. So we got the length of BC. Now we can write, see, we know this length we know. So this is perpendicular and this is base. So we need to find the value of this base, length of this base. So what is the relation between P and B? We know tan theta is related to perpendicular by base. So we can write, we know tan of theta equals to P by B. And what is P? P is this one. This is our P, perpendicular BC, and B is BD. So it is BC divided by BD, and theta is 60 degree. So write tan of 60 degree equals to BC. BC is how much? See, BC is 28.5. So write here 28.5 divided by BC. Now tan of 60 degree is root 3. So we can write here tan 60 degree is root 3, 28.5 divided by BC. So from here we can write BC equals to 28.5 divided by root 3. So this is the length of BC. Now again we need to find, this is the length of BD, not BC, this is BD. So this is BD, this is BD. Now we find this length, but we need to find this length, not this length. So for that we need to find, first we need to find the length of full this AB, the distance of this boy from this building. So if we find this total length, then what we will do, we will subtract this length, so we will easily get this length AD. So how we will get the total length AB? So from this triangle, see there is a triangle ABC. So again write from the triangle ABC. So you can write here from the triangle ABC. What is theta? Theta equals to 30 degree, and BC equals to, again same BC is 28.5. so here 28.5, right? BC is 28.5. we will find the value of AB, this total length. We will find this AB. So if you find this AB, then we know the value of BD, so we will subtract this and then we will get our answer. So again the relation is P by B. So we know tan theta we can write as P by B. Again this time P is BC and B is our AB. So see, this is our base. Since the angle is this, so the side opposite to this angle is P and this side will be B. So since we need the value of this, so we will find the relation between P and B. So we know the relation between P and B is by tan theta. So tan theta is, this time theta is 30 degree, BC is 28.5, AB we need to calculate. Again tan 30 is 1 by root 3. See, tan 60 is root 3 and tan 30 is 1 by root 3. So this is again 28.5 divided by AB. So from here we can write AB. So AB into 1 is AB and root 3 will be multiplied to 28.5. So ultimately 28.5 root 3. So this is the length of AB. So now we need to calculate this. We can calculate this AD. So AD equals to how much? AD equals to AB minus of BD. We know the value of AB. Also we know the value of BD. We calculated both this value. So we can find, therefore AD. So therefore AD equals to AB minus of BD. AB is, we just calculate this 28.5 root 3 minus BD is how much we calculate? 28.5 divided by root 3. 28.5 divided by root 3. Now you can simplify this as take LCM as root 3. So LCM is root 3. So multiply root 3 into root 3 will be 3. So 28.5 into 3 minus root 3 cancel. So it will be 1 into 28.5 into 28.5. So now we can write this is, see, 28.5 we can take common 28.5. so this is 3 minus of 1, that means ultimately 28.5, 3 minus 1 means 2 divided by root 3. So 28.5 into 2 means 57 divided by root 3. Now see, 1 root 3 is in denominator, so to cancel this, write 57 in a multiple of 3. So we can cancel that, this root 3. So 57 we can write as 19 into 3 divided by root 3. Now this root 3 and 1 root 3 will be cancelled from these 3. So that means this 3 we can write as root 3 into root 3. So this root 3 and root 3 cancel. Ultimately final answer is 19 root 3 meter. So this much distance he walked towards the building. The boy walked towards the building. So this is the final answer. So now let's see question number 7. So before solving question number 7, if you like my explanation of this video, then please like, comment and subscribe my YouTube channel. So in question number 7, see, it is given that from a point on the ground, the angle of elevation of the bottom and the top of a transmission tower fixed at the top of a 20-meter high building are 45 degree and 60 degree respectively. Find the height of the tower. So it says that a tower is fixed at the top of a 20-meter high building. So let's assume that this is the building. So it says that on the top of this building a tower is fixed. So suppose this is the tower which is on the top of this building. Now it says that this is the height of building is 20 meter. So the length of this is 20 meter. So see, it says that the angles of elevation of the bottom and the top of a transmission tower fixed at the top of a 20 meter high building are 45 degree and 60 degree. That means it says that from the bottom of this tower, so this is the bottom of tower. So from this bottom to the ground angle of elevation is 45 degree, and from the top of this tower the angle of elevation is 60 degree. So see, this is ground. Let's assume this is ground. So let me draw it clearly. So this is ground. Now it says that from this bottom of the tower the angle of elevation is 45 degree. So this is 45 degree, and from the top of the tower the angle of elevation is 60 degree. So this is angle of elevation from the top of the tower, this is 60 degree. Now we need to find the height of the tower. So we need to calculate this length. So let's assume that this is our A, this is B, this is C, and this is D. So that means we need to calculate this length CD. So for that what we need to do, so see, there is a two triangle. One is this A, B and C. This is one triangle. So from this triangle what we have, we know the length of this BC, so we can calculate this length AB. So if we calculate this AB, then we will consider this triangle. See, ABD. From this triangle we know the value of AB, and then we will find this BD. So we will find this total length. So from this total length, if you subtract this length, this much is 20. So from the total length, if we subtract this 20, then we will get this CD length. So I hope you understand this very easy concept. The first one is, we will consider this triangle. So from this triangle this length is given to you 20, so we will find this length. So after getting this length AB, after getting the value of AB, we will consider this triangle. The next triangle is ABD, the big triangle with angle 60 degree. So from the first triangle we will get the value of AB. So now we know this value, so we will find this side, that means BD. So from BD, if we find the value of BD, so after that we will subtract BC from this BD. So then we will easily get this CD. So now we will solve this question. So for that, just write from the figure, solution from the figure, write from the triangle. From the triangle, consider first triangle ABC. Theta is 45 degree. See, this triangle theta is 45 degree, and what else is given? BC. The length of BC is 20 meter. We will calculate AB. So if this is the angle, then the side opposite to this angle is P, and this is P. So we know the relation between P and B. So we know tan of angle theta is equals to, we can write as P by B. And what is P? P is BC, B is AB. Tan of theta is 45 degree. So tan of 45 degree, BC is 20, AB we need to calculate. So from tan of, we know the value of tan 45 is 1, 20 divided by AB. So from here we can write AB is equals to 20. So now we got the value of AB. AB is also 20. So now what we'll do, we will take this triangle ABD. So write again from triangle ABD. From triangle ABD, this time theta is 60 degree and AB equals to again 20. So see, from this triangle we know the value of this, since we just now calculate this AB. Now we will calculate this side BD. So BD we need to calculate. So right, again we know tan of theta will be P by B. And what is P? P is this perpendicular is BD and B base is AB. Now this time tan theta is 60 degree. BD is, we need to calculate this BD, and AB we just find the value of AB is 20. And now tan 60 is root 3 BD divided by 20. So from here we can write BD equals to 20 root 3. Now we have the value of BD. So we need to calculate this CD. So CD, how we will calculate? We will BD minus of BC. So write CD equals to, therefore we can write CD equals to BD minus of BC, and BD we just now calculate 20 root 3, and BC, it is given in the question that BC is 20 meter. So take 20 common from both of them. So here root 3 minus of 1. So this is the final answer. The length of CD is 20 root 3 minus of 1. So if you like my explanation, then please like, comment and subscribe my YouTube channel. In the next video we will solve the rest of the question. Thank you.